we will now look at a few examples of something that's called factoring by grouping, okay? Now, this is a little bit tough to decipher when to use sometimes. So here's what I'm going to say is I'm just going to make this like little checklist, right? So when we go through these things, we always check, you know, first it's like, okay, well, can I take out a GCF here? Right? Can I take out a greatest common factor? Right? And we look at this particular example, and we have a coefficient of 1 and 2 and 3 and 6, and you know, no, we can't take a greatest common factor out of all of those, right? Even this one has 3 x's, this one has 2 x's, 1 x, and then no x's, right? We can't take out a GCF, okay? And so we don't, right? And now we look, okay, so it's like we want to do an x chart, right? We want to factor this with our x chart, but it's like, okay, well, we try our x chart, and well, we don't have an a, b, and c term anymore, right? It's not quadratic. We have a third power here. This is a cubic function. Okay, so it's like, well, the x chart's no good, so we can't do that. Okay, well, now the next thing we can sort of jump to is if this is a 4-term expression, right? If this is 4 terms, okay, we want to check to see if factoring by grouping is an option. Okay, now you'll see why they call it factoring by grouping here in just a second. Okay, so factoring by grouping. Okay, so here's how this works. Okay, is we're going to look at this 4-term expression as 2 separate little math problems. Okay, and what I'm going to try to do is look at this first expression here and take out a greatest common factor out of that. Okay, well, I know that 1 and 2, they're both prime numbers, right? So I can't really take out any coefficients. However, I can take out 2 x's because they have 2 x's in common. So I'll take out x squared, okay? And if I divide by x squared and divide by x squared, I'll be left off with, it looks like x plus 2, okay? And so I'm in good shape to start, and I'll keep going here. And in this next particular part, I have 3x plus 6, right? Well, this is 3 and 6, and I know I can take out 3 from that, so I'll take out a positive 3 here, okay? And I'll see what's left over, right? So if I divide this by 3 and divide this by 3, I'll be left off with now, looks like x plus 2, okay? Now here's kind of what we have to see here by factoring by grouping, okay? It's that this x plus 2 and this x plus 2 match, okay? So we can think of x plus 2 as a factor of the red part, okay? And this x plus 2 as a factor of the blue part, and now we're going to factor out that whole part, okay? So I'm going to take off and you know, write this x plus 2 on the outside here, okay? And now I'm going to write what's left over. Okay, well, if I divide this part by x plus 2, and I divide this part by x plus 2, right? X plus 2 will cancel, and this will cancel, right? This will cancel, and this will cancel, and I'm just left off with x squared plus 3. Okay, and now this is actually my final answer. Okay, x squared plus 3 I can always check with an x chart to see if I can factor that. I will not be successful in that particular case, so now this is my final answer. Okay, I just factored this by grouping. Okay, and so let's take a look at a couple other examples here. It'll take some practice. Okay, so again, I'm going to go through my checklist. Okay, I'm going to look for GCF first. Okay, so I have, again, coefficients of 1, 4, 6, and 24. So can't really take anything out. Okay, now look at my x's. This first term has 3, second one has 2, third one has 1, last one has 0, so we don't have any x's in common, right? So I did my due diligence there, and I figured out, well, cannot take out a GCF. Okay, now I'm going to check with an x chart, right? So, but unfortunately here with an x chart, this is a polynomial, right? It's got 4 terms. I need to have it as a quadratic, and it's got to be, you know, either a trinomial or a binomial. So I can't do an x chart here. So now I'm going to go to factor by grouping. Okay, so I'll look at these first 2 terms here, and I'll see if I can take out a greatest common factor with those first 2 terms, right? Well, it looks like this term has 3 x's and this term has 2 x's, so I can definitely take out an x squared, right? And let's see what I'll have left over. right? If I divide each of these by its greatest common factor, I'll then have, it looks like x, and then I have a positive 4 here, so x plus 4. Okay, now let's look at this blue part. Right, so let's see what I can take out of this blue part. Right, it looks like I can take out a positive 6. Okay, I can't take out any x's because not both term has x's in them. But let's divide both of these by 6, and I'll be left over here. It looks like with x and then plus 4. Right, so we see that this common theme here of this matching. Right, so I have an x plus 4 here. I have an x plus 4 here. Okay, so we think of that as you know, x plus 4 is a factor of the red part, and x plus 4 is a factor of the blue part. So therefore, we can take out the x plus 4, and we can write out what's left over. Right? So if I divide this by x plus 4 and divide this by x plus 4, right? You know, those will cancel, and those will cancel or divide to 1, and now I have x squared plus 6 left over. Okay, and this is going to be my very final answer. Okay, so in the next video we'll look at a couple other examples of factor by grouping, but remember this usually happens when we can't take out a GCF, we can't use an X chart, and we have a 4-term polynomial. This is going to be the main time when we use factor by grouping.